Hello student, in this video we will discuss about fertilizers. So basically heading towards fertilizers, let us first know what is manure and what is fertilizer. Okay, so manure are the organic supplements which are provided or which are supplied in the field to grow crops or to supplement the plant growth to provide essential plant nutrients. Okay. Similarly, in case of fertilizer, fertilizer may be organic or inorganic in nature, which are supplemented, provided to the plant to supplement the plant growth. Okay, and they provide the plant nutrients in available form so that plant can absorb those nutrients. So basically, that is all about fertilizers. Fertilizers may be organic or inorganic in nature, like urea. Like your fertilizer urea, that is organic in nature as it contains carbon, whereas other fertilizers, basically all the synthetics that are produced in industries are considered as all the nutrient supplements that are produced in industries and that supply plant nutrients are called as fertilizers. Okay, so that may be organic or inorganic in nature. So example of organic fertilizer is urea. Okay. Now let us know about the historical developments of fertilizers, how fertilizer came into existence, and what was the first fertilizer that was used in that time. Okay, so the term fertilizer was first used by whom? That Fuller in 1661. Okay, so he is the one who first used the term fertilizer. Okay, so that was Fuller in 1661, and before that, which was used as fertilizer, so ammonium sulfate was used as a fertilizer in India before naming the word fertilizers. Okay, so ammonium sulfate was used. The next is in 1958, urea, ammonium chloride, and ASN were used. Okay, that these three were manufactured. Okay, so urea, you know that nitrogen, it is the most it is extensively used nitrogen fertilizer in India that contains 46% nitrogen. Okay, that is ammonium chloride, ammonium nitrate. Okay, now next is your in 1960 can in ammonium phosphate sulfate. Okay, that is APS. Okay, which was first complex fertilizer. Complex fertilizer means which contains more than one major nutrient. Okay, as you can see that the nutrient is N, O, P, and sulfur. Okay, so basically that contains more than two major nutrients that comes under your complex fertilizer. You know that is calcium ammonium nitrate, and it is usually it is neutral in nature and also known as Kisan Khan. Okay, so that is about CAN. Okay, so basically that was all about your historical development, which the term fertilizer was first used by Fuller in 1661, and before that in India ammonium sulfate was manufactured. Okay, and after that urea came into existence. In 96 and 66, nitrophosphate was manufactured. Okay. Then DAP was manufactured in 66 and 67. Okay. Now, what are the various terms that are related to fertilizer? First is your fertilizer grade. Okay. The next is a fertilizer ratio. What are the main fertilizer grade mean the guaranteed. Okay. So the nutrient should be in guaranteed proportion. Means the fertilizer should contain the guaranteed amount of nutrient in it. So that comes under your fertilizer grade. Means urea contains 46% of nitrogen. Okay, so that means the grade is that is the maximum guaranteed nutrient present in fertilizer. Okay, the next is the fertilizer ratio. Means the ratio of NP25 and K2O. Okay, so the ratio of these three nutrients present in any fertilizer, that is fertilizer ratio. Fertilizer conditioner means which are added to the fertilizer to improve to better the fertility status of the soil. Okay, the next is a coated fertilizer. Coated fertilizer means fertilizer is coated with some other material so that it can it can be act as slow release, and the fertilizer efficiency can be increased. Okay, so polynutrient fertilizer means poly means more. Okay, so more than one or two major nutrients. So that is your polynutrient fertilizer. And pop-up fertilizer means your starter fertilizer. Okay, your starting seedling fertilizer, that are your pop-up fertilizer or starter fertilizer. Okay, the next is your classification on the basis of nutrient content. Okay, so basically that are your state fertilizer. State fertilizer means which contains your one major nutrient, that is your state fertilizer. Okay, so that is your state fertilizer means which contain the nutrient content, okay, in higher amount, that is example is urea, that contains 46 one major nutrient, that is 46% nitrogen means one major nutrient. Nitrogen is present in case of urea. Okay, the next is your compounded complex fertilizer means when the fertilizer present contains more than two major nutrient. Okay, like more than two major nutrient, like your DAP, SSP. Okay, so they contain two major nutrient. So that is your what? Complex fertilizer. Okay, and now on the basis of nutrient concentration, NPK. Okay, so low analysis fertilizer means the nutrient concentration is low. Okay, and high analysis fertilizer means the nutrient concentration is very high. Okay, like your urea. Okay, urea is basically your high analysis fertilizer, and the example of DAP. Okay, DAP in like your urea. Okay, more than 25% of the basic nutrient is present, then that is called as high analysis. And if it is less than 25%, then it is called as low analysis fertilizer. Now next is the physical form, as the name suggests. If it is present in a solid form, then it is solid fertilizer, and if it is present in your liquid form, that it is called as liquid fertilizer. Okay, the next is on the residual action. Okay, if it causes the residual action of acidity in the soil, then it is called as acid forming fertilizer, like your ammonium fertilizers. Okay, they causes acidity in soil. The next is the alkaline forming fertilizer, which the residual action is alkaline in nature, that are your alkaline forming fertilizer. The next is your equivalent acidity and basicity. Okay, so how much calcium carbonate is needed to neutralize the acidic action of these fertilizers, so that is basically equivalent acidity, and the rest is your equivalent basicity. Okay, so maximum equivalent acidity contains ammonia, anhydrous ammonia, that contains 148, ammonium chloride, that contains 128, ammonium sulfate 120, urea 80, and ammonium nitrate 60. Similarly, calcium nitrate, that contains means the amount of CaCO3 present. Okay, calcium nitrate, BCP 25, sodium nitrate 29, and calcium cyanamide 63. Thank you.
Hello students, in this video lecture we are going to study about the soil fertility and the productivity. So first, starting with the first topic, that is the soil fertility. So how do we define soil fertility? See, soil fertility, it's the inherent capacity of a soil to supply the available nutrients. What does this mean? It means inherent capacity. That means a capacity or the characteristic or the trait of the soil that is present in it since it has been formed, or since it has formed from its parent material. So it carries those properties along with it from the very inception. Okay, so that is your inherent capacity of a soil to supply the available nutrients. Now, how do we say? Sometimes we say now that particular soil of this place is very fertile, or the particular soil of that place is not so fertile. How do we say that? We say that on the basis of how many proteins does that soil provide to the plant for the growth. Now, there's different areas. In India, if you see, different parts of the India have different kinds of soil in which the fertility varies from place to place. And not all of the soil can provide all of the nutrients. So how do we call a particular soil a fertile soil? we'll call a particular soil fertile soil if it provides all the essential nutrients that the plant needs in particular amount. Okay, so and that has to be like enough for the plant. So available nutrients to the plant in adequate amount. It should also be not just available. The nutrients should be available, but those should be available in an adequate amount. It should not be that nitrogen is present in the soil, but it's not enough for the plant. And that's why you must have seen that in most of the cases, or in almost all of the cases, we have to apply the external output. That means we have to apply the fertilizers in order to supplement the nutrient requirement of the plant, because the Indian soils are also deficient in many of the nutrients. So we can't say that all of the soils are very fertile in India. Okay. So soil fertility here, what does it mean? That at right proportion, at suitable proportion, should be able to provide the nutrients to the plants, and the plant should be able to complete its growth and development. Okay, so that is your soil fertility. Now, what are the different factors that affect this soil fertility? One are your natural factors or the pedogenic factors. Pedogenic factors means the more different factors. That means the soil, a particular soil that we have, what is it made of? It is made up of the parent material. Now, how was that parent material? Was the parent material too basic or too acidic, or did it had enough of minerals in it or not? Those minerals, that will all depend on what kind of parent material do we have. So if the parent material is rich in minerals, so it will lead to formation of more fertile soil. Okay. Second is your edaphic factors or the soil management factors. So you must have seen, it's not, you cannot manipulate the soil fertility in a very short period of time. It takes many years in order to change the fertility of a soil. Okay. So you must have seen that in some places, if we go for monoculture, that means we are growing only similar kind of crop every year for many years. So over the period of time, we say the soil fertility has gone down. Why is had gone down? Because particular amount of nutrients are being uprooted, or you can say are being taken away from the particular strata of the soil on regular basis, and it has not been replenished. So that's why these different edaphic factors or soil management factors also play a role in maintaining the soil fertility. Or if we go for overusing of any fertilizer, or we go for using of same kind of fertilizer over the years, we are not changing the cropping pattern, and we are not changing the type of fertilizer that we are using, or we are not providing adequate amount of fertilizer, or if we are providing extra amount of fertilizer, so that can also lead to what, for example, if we use urea for a very long time, so it may lead to acidity in the soil. Now this acidity will hamper some of the nutrients. You can say some of the nutrients may not be available to the plant. So there we can say that the soil fertility has gone down. Okay, so these factors affect the soil fertility. Second thing that is important for us is soil productivity. Now, how is soil productivity related to soil fertility? That we are going to see here. But first of all, what is soil productivity? See, it's related to production. And production of what? Of the crops. So how much of production, how much crop producing capacity or the ability of the soil is, that tells us about what? Soil productivity. Okay. And how is it measured? It is measured in the terms of yield or the biomass. That means how much of the biomass or how much of the yield can a particular soil support. Okay. How much of biomass it can produce. So that tells us what? Soil productivity. Now only if a soil is very fertile, it can have good productivity. If the soil is not fertile, it cannot have a good productivity. Okay. To be productive, yes, the soil must contain all 14 essential mineral nutrients. Now, why am I saying 14 essential mineral nutrients? Because we know we have 17 essential elements. Out of those 17, CHO is something that is obtained from the gases in the water. Other than that, we have other 14 essential elements. Those are the mineral nutrients. That means those are obtained from the soil. So those 14 essential nutrients have to be provided by the soil. Okay. Now, this statement is also very important that all productive soils are fertile, but not all fertile soils are productive. Because all of the soils that are fertile will be able to produce a good biomass. So all productive soil have to be fertile. But all the fertile soils, they may not be very productive, because what happens? Because productivity also depends on other factors as well. So it also depends on the climatic factors of any place, or it also depends on how the cultural operations have been done. So productivity can go up or down, but yeah, soil fertile, be the soil fertile or not, it will not affect the productivity. That means the productivity will be affected by various other factors as well. It will depend on the fertility, but it will also depend on other factors as well. Okay. Now, factors that are affecting your soil productivity are: first are your internal factors. So internal factors means the genetic factors or the hereditary factors of the soil. As I've said, that means the soil fertility. So here, soil fertility is basically the inherent, or you can say the genetic factor of the soil. Okay. Other than that, we have other external factors as well. So in external factors, we can have the climatic factors, whether the place had enough of rainfall in a particular year or not, or particular season or not, or there was enough of sunshine or not. That will also affect the soil productivity. Then it affects all the soil factors. If the soil had enough of moisture or not, if the porosity was enough or not, that can also affect the productivity. Then biotic factors, that may include the animals or the soil microorganisms or the other plants that are growing in the vicinity, or there may be weeds growing out there. Okay, then there are physiographic factors or the topographic factors that we call, that if a place is slopey, or if a place is leveled, or if it is in a tabletop manner, which kind of physiography do we have? Then anthropogenic factors, that means man-made factors, are also important. Okay. Now, methods of soil fertility evaluation. How do we evaluate the soil fertility? So, nutrient deficiency symptoms on plant. How do we know a particular soil has all the nutrients available in it or not? Okay, so nutrient deficiency, if the plant is showing the deficiency of certain nutrient, that means this nutrient is not present in the soil and is not available to the plant. Alright. Then plant analysis, we can go for plucking out the leaf of the plant, and then we can analyze a particular amount of nutrient, how much is the nutrient status of that plant. In that way also we can analyze whether the plant has uptaken enough of nutrient from the soil or not. If enough of nutrient is not available in the plant, that means it was not available to the plant, right? And we have different biological tests of the soils, which we can do that. Soil testing is there, in which we find the different macronutrients and micronutrients in the lab. Okay, modern approaches of soil fertility and evaluation and fertilization recommendation can be there. So these are the different fertility evaluation methods that we have. So this was it about the soil fertility and the productivity. Thank you for watching.
Hello guys, in this video we are going to discuss about soil conservation. So basically what soil conservation is. Okay, so conservation means we are going to conserve the soil, we are going to protect the soil which from being get eroded. Okay, so we are protecting the top layer of the soil from being get eroded. So that is basically soil conservation, and we'll observe the strategies to conserve the soil. Okay. So it is a set of management strategies for the prevention of soil being eroded from the earth surface. Okay, so whatever management strategies you are going to do to prevent it from being get eroded, so that comes under your soil conservation. Or become chemically altered by overuse, acidification, soil erosion. Okay, means all the problematic thing that will happen in case of soil. So need to protect from these. Okay, another chemical soil contamination to retain the fertility status of the soil. So that is basically soil conservation. Now what are the method of soil conservation? Okay, so first is your agronomic measures. Okay, so agronomic measures are applied where the slope is less than 2%. Okay, so in that cases agronomic measures are usually applied. Okay, so first is your conservation tillage. Okay, so conservation tillage means you are going to reduce the number of tillage operations so as to less disturb the soil structure, and also we are using the residue that is present over there. Okay, so we are using that residue only which is present over there, so that is conservation tillage. Now next is your deep tillage. Okay, so deep tillage means we are going to break, the main aim is to break the hard pan. Okay, so that is done by the chisel plow. And what is the use of deep tillage? So it should be done after 3 years. It is suggested that particularly 3 to 5 years we have to go for deep tillage so as to break the hard pan. Okay, so break the hard pan and to permit the aeration and water infiltration. Okay, so that the fertility should be maintained. So in that case deep tillage should be done. Now next is contour farming. Contour farming is basically done in case of hill or terraces, and we need to sow the crops across the slope. That is contour farming. Okay, like that is means in the hills or terraces you will observe that there is a contour farming, and in that, and this is basically what contour farming is. Okay, and the next is mulching. Mulching means we are spreading some natural mulch or some polythene mulch. Okay, man-made mulch, so as to protect the moisture from the soil. So main aim is to protect the moisture, as well as if you are placing that mulch in the soil, then it will prevent the soil from being get eroded or from the direct contact of the sun or the rain. Okay, from the hitting of direct heat or rain. Okay, so that is basically mulching. Now next is growing of cover crops. Okay, so what are cover crops? Cover crops are those close grown crops which are grown in the soil to protect it from any kind of erosion. Okay, so they will hold the ground and does not permit the air or the water to get eroded from the surface. Okay, so they will hold the soil, and so that is your close grown crops. Okay, so these are cover crops which hold the soil so as to prevent it from being get eroded. Now next is strip cropping. Okay, so basically strip cropping means we are going to plant or sow the crops in such a way that in narrow strips, in such a way that these strips are like erosion permitting and erosion resistant crops. Okay, so we are growing erosion permitting crops and erosion resistant crop in alternate strips, and that is called as strip cropping. And our main aim is to prevent from erosion. Okay, Now next is mixed cropping. Mixed cropping means we are growing different kind of crops together so as to maintain the fertility status of the soil. Okay, so the as you know that if we are going for pulse crop production, then it will obviously fix some nitrogen and which will may be beneficial for the growth of cereal crops. Okay, so that is mixed cropping. So here you can see that these are different kind of strategies. Next are your engineering measures. Okay, so engineering measures are employed where the slope is greater than 2%. Okay, if the slope is greater than 2%, then we go for engineering measures, and these are bunding, terracing, trenching, and subsoiling. Okay, now we'll understand that what are these measures. Okay, so first is your bunding. Okay, so bunding means we are constructing an embankment so as to protect the soil from erosion. Okay, so it is an earthen embankment constructed to control runoff and minimize soil erosion. Okay, so we will construct some embankment like this so that the water can water can easily be flowed out from the field, and the soil should be protect from the erosion. Okay, so that is basically bunding. Now these bunding is differentiated into contour bunding and graded bunding. Okay, so what is contour bunding and what is graded bunding? So if the slope is about 6%, then we go for contour bunding, and it is employed in the area where the rainfall is less than 600 mm. And what we do in contour bunding, this is the practice consists in making a narrow base embankment at intervals across the slope of a land on a level that it is along the contour. Okay, so we are sloping it. We are basically constructing an embankment across the slope of land. Okay, so that is contour bunding, and it is employed where the slope is about 6% and rainfall is less than 600 mm. Okay, next is graded bunding. Okay, so graded bunding is adopted where the slope is about 2 to 10% and the rainfall is more than 600 mm. Okay, so in that cases we will go for graded bunding. Okay, so that is bunding. Now we will study about terracing. Okay, so basically terracing is an earth embankment constructed across the slope. Okay, so it is basically an embankment which is constructed across the slope. Okay, so it is an intercept to land slope and divide the sloping land surface into strips. Okay, so it will it will transform the steep slope into narrow strips. Okay, so that is terracing, and it will be classified into broad-based terraces and bench terraces. Okay, so bench terraces is employed here where the slope is 16 to 33%. Okay, now what is broad-based terraces? Okay, so these are adapted where the main purpose is either to remove or retain water. Okay, if we are going to remove our aim is to remove the water or to retain the water on the sloping land, so we will go for broad base terraces, and the purpose of bench terracing is mainly to reduce the land slope. Okay, and if we are going to reduce the steep slope, so that then we will go for bench terrace. Okay, now we will observe that what is bench terracing. As we have already discussed that if we are going to reduce the steep slope, then that we will go for bench terracing, and it is adopted where the slope is basically 16 to 33%. Okay, then we will go for bench terracing. So the original bench terrace system consists of a series of flat shelf-like areas that convert a steep slope of how many percent? That is 20 to 30% to a series of level or nearly level benches. Okay, we need to reduce the slope. Next is construction of series of platforms along contours cut into hill slopes in a strip-like formation, and we will create the slope in such a step-like formation. So that is basically bench terracing. Now when we talk about the problematic soils management practices, means if we are going for the maintaining the fertility status of the soil, then these methods are your soil organism. Okay, soil organism, they basically increase the fertility status of the soil like earthworm. Okay, so we can go for soil organisms So that's all for this video. Thank you for watching the video.